When someone promises you 99.9% availability, what does that actually mean? For my team, that promise raised a simple but profound question. How on earth do we even calculate that? We needed a way to turn this vague goal into something real, something we could measure and act on. That's when we discovered the power of SLOs, or service level objectives. Think of an SLO not just as a target, but as an enforceable contract you make with your users. It's a promise that you can and will keep. Now, let's break down these concepts, because I know they can sound a bit academic at first. Imagine you're running a logistics company. Your service level objective, or SLO, is your public commitment letter. It boldly states, we will deliver 99.9% of our packages on time. It's the target, the promise you're aiming for. Next, you need a way to track if you're actually meeting that promise. That's where the service level indicator, or SLI, comes in. This is your real-time dashboard showing the actual on-time delivery rate. It's the raw data, the proof. Is it 99.95%? Great. Is it 99.8%? We've got a problem. The SLI is the metric that measures your performance against your SLO. So what happens if you don't meet your objective? This brings us to the service level agreement, or SLA. In our logistics analogy, this is the penalty clause in your contract. It says, if our on-time delivery rate drops below 99.9%, we will compensate you. The SLA adds financial teeth to your promise, making it a serious business commitment. It's the part that says, we're so confident in our service that we'll pay you if we fail. This leads us to a really crucial concept, the error budget. If your goal is 99.9% availability, that means you have a 0.1% margin for error. This isn't a license to be sloppy. It's a calculated risk allowance. It's the pre-approved budget for things to go wrong. In our logistics company, this 0.1% is the small number of packages you allowed to deliver late without breaking your promise. This error budget is incredibly empowering. It allows your team to innovate, to take risks, and to push new features as long as they stay within that budget. You can spend your error budget on planned maintenance, new deployments, or even on unavoidable, unexpected failures. The core insight here is that SLOs transform abstract ideas about quality or reliability into verifiable, numerical contracts. That 99.9% promise is no longer just a marketing slogan. It's a concrete number defined by your SLI. The consequences are spelled out by your SLA. And your room for maneuver is defined by your error budget. Everyone on the team, from developers to product managers to operations, is suddenly speaking the same language. We're no longer arguing about whether the system feels slow or flaky. Instead, we're asking, are we meeting our SLO? How much of our error budget is left for the month? This data-driven approach allows us to make rational, objective decisions. Should we push that risky new feature? Let's check the error budget. If it's healthy, maybe we can afford the risk. If it's nearly depleted, we need to focus on stability first. It aligns everyone around a single, unified standard of what good enough truly means. It's a game changer for team collaboration and focus. So armed with this newfound clarity, my team went all in. We set up our SLOs, configured our SLIs, and defined our error budgets. We were ready. We finally had a system that could tell us exactly when our service quality was dipping. We turned on the monitoring, and then the alerts started. At first, it was a trickle. Then, it became a flood. It felt like standing in a snowstorm, with alerts pouring in from every direction, burying us. We had solved the problem of not knowing when things were wrong, only to create a new, even bigger problem. Constant, overwhelming noise. And that's when we learned a hard lesson. In the world of system reliability, noise is far more dangerous than silence. Silence is a problem you can eventually find and fix. Noise, on the other hand, actively hides the real problems. It trains you to ignore alerts, leading to a state of alert fatigue where the one critical notification that truly matters gets lost in a sea of meaningless chatter. That's the moment your entire system can come crashing down, not because you weren't warned, but because you were warned about everything, all the time. How do you build a monitoring system that tells you what you need to know without drowning you in noise? How do you make your alerts meaningful again? That's a huge challenge, and it's exactly what we're going to dive into next time. We'll explore the techniques we use to tame the alert storm and build a system that gives us signal, not noise. Thanks so much for watching. If you've ever felt buried in alerts or struggled to define what good service really means, I hope this was helpful. Be sure to subscribe and hit that notification bell so you don't miss the next video where we tackle the problem of alert noise head-on. See you in the next one.